Okay, so we're back. Round 2 of this antiderivatives, except this time we're going to find a particular solution. So remember that antiderivatives are just translations of one another. When you perform the antidifferentiation, you find in it, the value of an indefinite integral. You are finding just an antiderivative, one of many. So giving you some sort of initial condition, basically an initial condition is nothing more than a point on the function. I'll jot that down. It's just a point on the function. If you know that point on the function, we can find an actual particular solution to an antiderivative equation. So, for example, let's say we're asked to integrate or find the antiderivative of 3x squared minus 1. From our last lesson, we know what we have to do. Make sure it's in that power rule format. I'm going to take the exponent, I'm going to add an exponent or a 1 to each exponent, and then I'm going to divide by the result. So that's just going to get me 3x to the third divided by 3 minus, what's the only thing I could derive to get a 1 would be x, divided obviously by 1. And then, of course, your plus c. If we simplify that, that just becomes x cubed minus x plus c. We refer to this as the general solution. Again, because that's just one possibility. That constant can change. So for example, in my calculator, I've put x cubed minus x plus some random constant into my y equals screen. I put 4 functions on there just to see what they look like when we graph. The only thing different that we're going to see about all 3 of these functions is the fact that they've just been translated or moved, in this case, up or down the x-axis. So that plus c is just making that movement. So these are all possible solutions, hence again, a general solution. So now I can narrow this a little bit and I can give you an initial condition and I can tell you, if I give you the piece of information, and I could say f of 2 is equal to 4. Given that, you now know something about this particular value. This is just, again, an initial condition, which is a point on the function. And it's nothing more than an x value and a y value. So going back to our Algebra 1 days, this is the x value, this is a y value. We're just going to plug it in. So this function that you have here, when you found this, you noticed if you looked at CalcChat, it usually represents the antiderivative with the capital F. If you used a regular, that kind of squiggly cursive F, I really wouldn't care one way or the other. I know what you're dealing with here. But we still know that this is a y value. I'm going to replace that y value with a 4. That equals 2 cubed minus 2 plus c. So just a straight up Algebra 1 substitution problem. 4 equals 8 minus 2 plus c. That gets me 6. C equals negative 2. So this particular function, so this particular antiderivative with this specific point on the curve has a particular solution, and we would say f of x is equal to x cubed minus x minus 2. So it's no longer just an antiderivative, it is the antiderivative given the fact that our function goes through the point 2, 4. So now we have a particular solution. So it's just one step above and beyond what you already were doing with the antiderivatives and indefinite integration, or indefinite integrals, is now you find that general solution. You're going to have some sort of initial condition given. You're going to plug it in to that function and find C. Riveting, I'm sure. So of course, let's do another example. Practices a couple of things for us here. So let's say I say my derivative is 3 secant squared x minus x. I'm given the fact that f of 2 equals -8. So if I want to find an antiderivative for this, or the antiderivative of 2 -8, here's my derivative. Here's my particular solution, my initial condition. So I am just going to integrate. Remember, when you are doing the integral symbol and such, you better have a dx to go with it. So this integrand or integral sign does not go anywhere without this dx. And again, these pieces, again, what this is called, this, which you are integrating, is the integrand, integral symbol, and that tells you what you're integrating with respect to. All right, so obviously we need to know something about secant squared. 3 is just a constant, so we kind of just let him chill. We can always move him out in front if you like, in front of the integral symbol. Secant squared, we know that is the derivative of tangent. So that becomes 3 tangent x. There's your minus. Integral of x happens to be x squared. Don't forget to divide by 2. And then there's your plus c. So general solution. So again, when the question comes up, when do I use the plus c? Always when you're doing an antiderivative. Except now we're going to take this one step further. We're going to find the actual function with this condition. So again, I have my x value and a y value. So I'm going to substitute that in. So 3 tangent of 2 minus 2 squared over 2 plus c. I don't know about you, but I don't know the tangent of 2. So I'm going to make sure my calculator's in the right mode. Yep, I'm in the right mode. Let my calculator do a little bit of work here for this. So 3 times the tangent of 2 gives me that fabulous number. 5. That gets me minus 2 plus c, -8. So c is equal to 0.555. There's my value of c. So I can say that my function, the original function, f of x, is equal to 3 tangent of x minus 1/2 x squared plus 0.555. Okay. Now I would encourage you to stop, pause. I'm going to, well, as soon as I give you the problem, pause it, try it, see if you get yourselves the right answer. And then I have one to show you with how we can use the second derivative and then some elements of the first derivative. So I would say try this one on your own. Given the fact that you have f prime of x is equal to 3/4 x plus 7, and f of -8 is equal to 12. So find me that particular solution. Okay, hopefully you paused, got an answer. Let's see if your answer is right. Derivative, information about the original function, we're going to integrate. So I'm going to integrate 3/4 x plus 7 dx. Again, don't forget that dx. So I take my 3/4. I've got that multiplied by x squared divided by 2. 7x plus c. Don't forget your plus c. So as of right now, a general solution would be 3/8 x squared plus 7x plus c. I can find the actual function itself by plugging in the values. Goes in for y, this goes in for x. So 12 equals squared. Thanks for calculators, so I don't have to think as much. Eight. Looks like that's all negative 32. So C should equal 44. Put it all together. My particular solution is 3/8 x squared plus 7x plus 44. So hopefully that's what you got too. All right, now I'm just going back to box these because I want to. And one last one. Let's take a look at one last example, and then you should be good to go with particular solutions. Again, it's just knowing again your differentiation rules and realize again that you're just going backwards. All right, last one. Let's say I've given you the second derivative of x is equal to x squared. I've given you the fact that the value of 0 of the first derivative is 8. And the value at 0 happens to be 4. And I want to find a particular solution. So I need to go back. I want to find f of x. And I'm going to use all this information to help me do that. Well, if you can differentiate once and we can differentiate twice, there isn't anything to stop us from integrating more than once as well. So it should make sense that to get the first derivative, I would have to integrate the second derivative. And then to get the first or the original function, I'm going to integrate the first one. But we'll start here. So if I'm trying to find the first derivative, I'm going to integrate the second derivative. So that means really integrating the function x squared. So f prime of x is going to equal x to the third power divided by 3 plus c. Now before I go on and try to find the original function, I'm going to take some of the information I already know. I know the value at 0 at 8, so that's going to allow me to find the value of c for my first derivative function. So 8 is equal to x cubed divided by 3 plus c. Oops, needed to actually put in a value of 0. Don't worry, even at home, always have some white outline around. It is my life. Oh, I like 0 cubed. 0 cubed does nothing. So c is 8. So now we know the first derivative of this function with all of these conditions is 1/3 x cubed plus 8. So back to the drawing board to find that original function, the antiderivative. I'm going to integrate the first derivative, which means I'm going to take that 1/3 x cubed plus 8, and we'll integrate it. So that means I've got this 1/3, add 1 to this, divide by that. 8 is just a constant, so antiderivative back to that would give me x. And then you've got another plus c. So our general solution, x to the 4th over 12 plus 8x plus c. But I know f to the 0, or f of 0 equals 4, so I can find my c. So 4 equals 0 to the 4th divided by 12. Man, love the number 0. Wipes everything out. So c in this case is equal to 4. So we can say with confidence then, our original function, our particular solution to this particular pieces of information, here is the specific function. Again, given the restrictions that f prime of 0 is equal to 8, f of 0 is equal to 4, and the second derivative was x squared. Good fun stuff, right? Good healthy fun. All right, enjoy.